Greetings and a warm welcome to ChenMatrix Online Academy, your gateway to success in KCSE and IGCSE exams. Need exam preparation assistance and online coaching? Reach us on WhatsApp at the number shown or drop an email to muimaken3@gmail.com. Now, I'm honored to extend a humble privilege as we introduce our esteemed tutor, Engineer Ken Wima, who will expertly guide us through this insightful video tutorial. A hearty welcome, sir.
Thank you very much. Thank you. I appreciate for that introduction. Today we are going to have a look at sequence and series. We are going to look at two types of series as shown in the outline. We are going to start with arithmetic series and arithmetic progression as the first part of the tutorial. The second part is an introduction to geometric series in which we'll have to look at geometric progression. Next is we're going to look at a few examples on arithmetic progression and geometric progression that shall be tied together with arithmetic series and geometric series. On to the arithmetic progression. Now, even before we look at this type of series and progression, let me just mention a few other series and progression that exists in the world of mathematics. In advanced maths, we have series, sequence such as Fibonacci sequence. We also have binomial sequence and binomial series. We also have the Taylor series and Maclaurin series. Now, those are the type of series that exists. There are more and more type of series. But now, what is sequence? We have to understand what sequence is. Sequence is another meaning of progression. In a mathematical sense, a sequence is just a pattern. It is the way numbers are arranged in a certain order. That is what is called sequence. Now, let me break it down to let us boil it down to arithmetic progression and geometric progression. Arithmetic progression is a sequence of numbers in which the difference between any two consecutive terms is a constant. Now, what is the meaning of the word sequence? Sequence is the pattern. So we need to understand that. It does not go all that without acknowledging the guy who came up with the concept of arithmetic progression. That is a German mathematician by the name Carl Friedrich Gauss from 1977 to 1885. This is the guy who came up with the arithmetic progression formula that we use today. Now, let us look at the formula itself. If we want to get a sequence, the next sequence, or the next number, we have to look at A, which is A is the first term. You can see A is the first term there, plus n minus 1. N is the number of term or the number of terms. And then D is the common difference, the difference that is common. And then when you apply this formula straight away, you're going to get the next number. Now, this is an example of an arithmetic progression or the arithmetic sequence. Now look at the first term, which is 2. 2 plus 3, we get 5. 5 plus 3, we get 8. 8 plus 3, we get 11. So you can guess the next number, which is 11 plus 3, 14. Such a sequence qualifies to be called an arithmetic progression. Now, look at this. The common difference is 3, A is 2, N is 5. For instance, we would like to get the third term. This is the first term, second term, the third term. And then we apply this formula. So, our first term, you go just to plug 2 here. You plug 3 because it's the third term. 3 minus 1 is 2. Common difference is 3. So 3 times 2, 6. 6 plus 2, 8. So that is how we get the nth term of an arithmetic progression. Now, what if maybe you want to sum up all the terms defined? We want to sum up all the terms defined. What are we going to do? We use what is called arithmetic series. Arithmetic series is the sum of the first n terms of an arithmetic progression. Now look at these terms that we've listed here, which are part of the arithmetic progression. There are how many? There are 1, 2, 3, 4. We have 4 terms there. Let's say we want to get the sum of all these. We are going to apply this formula, or rather, we can just sum them manually. Say 2 plus 5 plus 8 plus 11. 2 plus 5, 7 plus 8, 15. 15 plus 11, 26. Here it is. But now I would like you to verify whether it's going to give you 26 by applying this formula here. This formula sums up all the values within that particular sequence. Now, if let's say we have 50 terms, it will be very, very tiresome to do all the manual way. So the formula, the advantage of using this formula is that you can even work out the series or the sum of 100 terms or 1,000 terms. I think that is a very nice introduction in arithmetic progression. So let us go to the next part, that is the geometric progression. So geometric progression. What is geometric progression? Geometric progression is also known as geometric sequence. It's a sequence of numbers in which each term after the first is found by multiplying the previous term by a constant factor called common ratio. The word constant factor carries some weight, because when you talk about a factor, then there should be a multiple. In mathematical language, we can say that is a multiple. And what is the name of that multiple? That multiple, which is also a constant, is known as a common ratio, denoted by R. Now, here's a formula for getting, but even before we go to the formula, I would like us to look at this sequence here. Look at 2. 6 divided by 2, you get 3. 18 divided by 6, you get 3. So that means they have a common multiple. It is, you have to multiply a number to get the next number. Multiply this number by 3, get 18. 18 times 3, you're going to get 54. A is 2, R is 3. R is the common ratio, N is the number of terms. In this case, the number of terms are 3. We can use this formula to calculate the next term or the nth term of a geometric progression. Now, A, which is 2 times R, which is 3, to the power n minus 1. N is 3. 3 minus 1 is 2. Let's say, for instance, we want the third term. So 3 minus 1 is 2, and r is 3. So 3 squared is 9. 9 times this 2 is 18. That's how we get 18. Now, but you can even get the 50th or 100th term using this particular formula. You can see that the symbols are already defined here. Now let us go to geometric progression. Before we even look at the formula, it's very important that we look at how this can be added manually. 2 plus 6 is 8. 8 plus 18 is 26. Geometric progression is just the sum of the terms in a geometric geometric series is the sum of geometric progression. So the sum of the terms in a geometric progression is given by this formula, but we have already added manually. So 2 plus 6 plus 18 is 26, and therefore we can verify using this formula. But here there are two conditions. Condition number 1, this formula is used when the value of r, the common ratio, is greater than 1. Then what happens? r power n minus 1 subtract 1 over r minus 1 is multiplied by a. When the value of r is less than 1, then we say 1 minus r to the power n minus 1 over 1 minus 1. So that is the difference when r is greater than 1 and r is less than 1. You can as well use this formula to verify whether you're going to get 26, bearing in mind that the value of r is greater than 1, because in this case r is 3. Now that we have introduced ourselves to these particular concepts, it is very prudent that we go straight to the examples. In the first example, the first term of an arithmetic progression, with an arithmetic progression with 6 terms is P, and its common difference is C. Another AP with the 5 terms has also its first term as P and the common difference of D. The last terms of the first two arithmetic progressions are equal. So let me highlight something here. We have the first term of the AP, okay, highlight that, with the 6 terms. The first term has 6 terms. The first AP has 6 terms, and the P is P. The first term is P, and it has a common difference C. Another AP with the 5 terms, so that is the second AP, has also its first term as P. So in this case, you realize that this is C and this is the common term. Both of them have the same common term. The first term, the first AP has first term as P. So the first arithmetic progression, first term is P. The second arithmetic progression, first term is P. What about the common difference? The common difference of the first arithmetic progression is C. The common difference of the second arithmetic progression is D. And you look at it and you realize also that the last 2 terms of the AP or arithmetic progression are equal. They are equal, the last terms. So, in this case, we are going to make use of this formula. This formula is the one that you're going to make use of it. But even before we go to the solution, I would like to engage you in thinking. And how are we going to think about? Let us think together. If we want the nth term, let's say we want to look at the first AP. We want to look at the first AP. If you want to look at the first AP, we are going to say that the nth term will be equal to the first term P. The first term is the same plus the nth term. This nth term here, we substitute with the 6 because the first term is 6. Are you seeing that? 6. Substitute 6. So 6 minus 1, 5. So that is going to be 5. But the common difference is C. The common difference is C. Look at that C. So the common difference is C. And that is the last term of the first AP. Let us now look at the second AP. The second AP is equal to, they have the same common term P. But the second AP has a common difference D, not C. So that is P plus, but how many terms? It has 5 terms. 5 terms. Now 5 minus 1 is 4. So that becomes 4D. Now that the two are equal, we are going to equate them. Let us see the solution. So T1, which is equation for the first arithmetic progression, is P plus 5C, like we have seen before. The second one, T2, which is the second arithmetic progression, has the equation P plus 4D. And because in the question it has been stated clearly that the two equations are equal, so we're going to equate them like this. Now, when you equate them, P cancels. When P cancels, we remain 5C is equal to 4D. The question is asking, express D in terms of C. So we want to express D in terms of C. So D is equal to 5 over 4C. That's the value of D in terms of C. Let us go to the next part of the question, part B. Given that, let me get my pen. I can change the color. Let me change the color. Let me use a green color. Now, given that the fourth term of the second arithmetic progression exceeds the fourth term of the first one by 1.5 or 1.5, find the value of C and D. Now, once again, I would like us to think together. Let us think together before we look at the solutions. Now, the fourth term of the second, so if you talk about the fourth term, we are going to substitute this n with 4. So 4 minus 1 is 3. So the fourth term, the first term is P, and the fourth term is 4 minus 1, going to get 3. The common difference is C. Don't forget, for the first one, for the second one, the common difference is D. For the first one, the common difference is C. So, what about the second? But you realize that the fourth term of the second is more than the fourth term of the first by 10, by 1.5, not by 10, it is by 1.5. Let us see. P plus 3D, that is the second, P minus P plus 3C, that is the first, is equal to 1.5. And 3D minus, when you open the bracket and you simplify, that is assume that we have opened the bracket, simplify, 3D minus 3C is equal to 3 over 2, because 1.5 is equal to 3 over 2. Now substituting for D, we have 3 is times multiplied by 5 over 4C minus 3C is equal to 3 over 2. Evaluating for C, for D, for D and C, we find out that D is equal to 2.5 and C is equal to 2. Now let me just briefly explain why these calculations were rendered. Now this negative there, this negative multiplied by this negative, this becomes negative. So you need to be very careful with that. And then now when we collect the like terms together, it boils down to 3D minus 3C is equal to 3 over 2. And here, what has just happened is that we have decided to substitute P. This one is equal to D. Maybe I can take you back to the prior part of this problem. Can take you back. You see that D is equal to 5 over 4C, and that is why we have decided to substitute D with the 5 over 4C. Now after doing the evaluation, the value of C is 2, and then now we can substitute for C, then get the value of D as 2.5. Let's go to the last part of this particular problem. Calculate the value of P if the sum of the terms of the first AP is 10 more than the terms of the second AP. The value of P if the sum of the terms of the first AP, the first arithmetic progression, is 10 more than the terms of the second arithmetic progression. Now, let us get to understand what you're supposed to calculate. The question is asking for the sum. For the sum, we have to know what sum means. And the first AP is 10 more than the second AP. What is sum? Sum is series. Sum is just the same as saying series. So the formula for getting arithmetic series will be very important, and therefore let us use it. So let us use the formula. Now we want to get the first expression, that is of the first arithmetic progression, and arithmetic series, and then you get the second expression, that is of the second arithmetic series, and then after that we can form an equation. Let us know what is provided. N is not provided. N is not provided in this particular part. It isn't provided, but we are told that the last terms for the first is 6. So we are going to substitute 6 here. That is for the second, for this first. And then what are you going to substitute? Here we are going to substitute 6 for the second. And then D, the common difference for the second is 2, or sorry, for the first is C, for which the value of C you've gotten is 2. Okay, don't forget that. Now, what we shall be finding is the value of B. Now, we remember that A, the first term, is B for both first and the second. Now, that will be the equation for the first. What about the second? The second one, we are going to substitute 5 here with the N. Substitute P here. P will be common. 5 here. Then substitute with the 2.5, because the common difference is 2.5 for the second. And then we are going to say the terms of AP is 10 more than that. So you're going to say the second is terms of the first AP is 10 more than the terms of the second AP. You're going to say the first AP is equal to the second plus 10. So let us see the solution. So we have substituted 6 here, like we have seen, 6 in N for the first series. 2 instead, where we have A, we substitute with a P. Let me use a highlighter, a laser highlighter. So here we have A, we have substituted with the P. This is 6. 6 minus 1 is 5, and the common difference here, it is C, because for the first AP, common difference is C. Maybe we can go back a little bit. Here it is C. Okay, so now let us continue. So this is the first expression. The second expression is the expression for the second arithmetic progression. We have substituted 5 where we have N, and the P still, the value of A still remains P, and because this N is 5, 5 minus 1, we get 4, and the value of P is 2.5. Now from the question, S1, which is the first AP, is equal to the second AP plus 10. While we say plus 10, look at this 10 here. Now, after simplifying all these expressions, of which I'm assuming that you should be able to, I bet that it is not very difficult to do so. It boils down to this: 6P plus 30 is equal to 5P plus 25 plus 10, and the value of P is 5. So let us go to the second example of this particular problem. The first term of an arithmetic progression is 2. The sum of the first 8 terms of the AP is 156. Find the common difference of the AP. Now, what are you going to do? I just want to show the substitutions that you are going to do to make the substitutions that we are going to make as regard to this particular formula. Now that the word sum has been mentioned, just know that we are supposed to calculate the series, not the sequence or the progression. So you're going to use arithmetic series formula. This formula is shown here. Now, we are told that the first term is 2. So let me write 2 there. Let me overlay 2 there. And it has 8 terms. So we already have n as 8. We already have n as 8. And then it equates to 156. So can you guess what is not provided? It's supposed to be found out. Most probably it must be D. D is the missing. D is unknown. So let us see in the solution. The solution, since A is 2 and all the others have already been given, so 8, n is 8, n is 8, A is 2, n is 8, C 8 minus 1. Common difference is the unknown, is equal to 156. So you just do the calculations, and then you arrive at D is equal to 5. Now let us go to the second problem, the second part of the problem. Given that the sum of the first n terms of the AP is 416, find n. Now here we are given what and what? We are given the sum. We are supposed to use the common difference that has been provided to get n. How are we going to go about it? It is very simple. We still use the substitution. N is not given. 2, can't use 2 as the A. The common difference is 5, and that is that. When you do the manipulations, it boils down to a quadratic equation. So you're going to select the method that you're going to use to simplify, or rather get n, either factorization method, either completing the square method, graphical method, quadratic formula. But I think in this case, the quadratic formula is more relevant. So n is equal to 13. So remember, when you're dealing with a arithmetic series and you're supposed to get n, just know that at one point or at any point you must solve a quadratic equation, because n appears here and it also appears here. You will multiply n times n. Let us go to the last example of this particular material content. The third, fifth, and eighth terms of another arithmetic progression form the first 3 terms of a geometric progression. The first 3 terms form the third, fifth, and eighth of terms of AP form the first 3 geometric progression. You are going to see that when we started doing the examples, we have not touched on geometric progression. Now here is where the geometric progression comes into play. And I think in this particular example, we are going to see how arithmetic progression blends well with geometric progression, or rather the kind of integration between the 2 progressions. Now, let us go to the question once again. The third, fifth, and the eighth terms of another AP form the first 3 terms of geometric progression. If the common difference of the arithmetic progression is 3, find the first term of the geometric progression. So, find the first term of the geometric progression. I would like us, let me pick a different color. I think I have used green. Let me pick red. Yes, I've picked red. Now, the third, I want us to understand that the third AP is the first GP. This is the second geometric term, and this is the third. This is the first, second, the third. Why? Because they form the first three terms of the geometric progression. Okay, so we have two progression. We have arithmetic and geometric. So we have the third arithmetic progression is the first. The fifth AP is the second GP. The eighth AP is the third GP. So they have to follow that particular order. So if the common difference of the AP is 3, find the first term of the GP. So the first term of the GP, we have said it is the third term of the AP. So you're going to substitute 3 here in N, and A we don't know. We have the common difference. Yes, it's given 3. We have find the first term of the GP. Okay. Do you have the first? Rather, do you have the third term? Can we get the third term? Let's go back. The value of N is 13. So, sorry, that is some different. We have the third term. Okay, now let us see the solution. So the first 3 terms of the GP are A plus 2D, A plus 4D, A plus. Let me try to explain how this has come. The first term of the GP. So the first term of the GP will be expressed in terms of A. So we have said that is A plus 3 minus 1 is 2D. That is the first term, which is the third term of the AP. The second term, we're just going to substitute 5 here. So A plus 5 minus 1 is 4. So A plus 4D. A plus 4D. And you're going to do the same. That for the 8th term is going to be A plus 7D. Now let us go to the solution. I think to be very precise, we ought to express the first term of the AP, the second term of the AP, and the third term of the AP. We want to get A, but we have to express first of all all these terms in terms of AP. Sorry, in terms of A. Bear in mind this expression here. Let me use a highlighter to highlight. Let me use a different color. Let me use a different color that I think I haven't used. But even black color is a color. So that is the third term of the AP. This is, let me check, the 5th term. Yeah, the 5th term. And this is the 8th term of the AP. And now let us see what has happened. What has happened with these numbers? Where are these numbers coming from? Or rather, where are these expressions coming from? We have all been told in the question that D is equal to 3. So it is just a simple multiplication by 3. we have all been told that D is equal to 3. So times 3. So 2 times 3, 2 times 3 is 6. 4 times 3, that is 12. 7 times 3, that is 21. So you have seen how these particular expressions have changed. And now we want to get the common to have an expression that will give us A. Before I come to this stage of common ratio, I would like us to think in this manner. Try to reason this manner. We have two numbers. We have the following numbers, 3 numbers. 4. We have 8. And then 4 times 2 is 8. 8 times 2, 16. Now this is a geometric progression. How do we get the common ratio? Common ratio is given by 8 divided by 4, which is also equal to 16 divided by 8. Oh, sorry, 16 divided by 8. So 8 divided by 4 is equal to 16 divided by 8. In other words, we are taking the number that comes after divided by the number that is just before. So 8 is bigger number. 8 over 4 is equal to 16 over 8. And that will give you 2. That is equal to 2. That is equal to 2. Now, that is the same analogy we are going to apply here. We are going to say this divided by this is equal to that expression. Let me use a highlighter here. We are going to say this, because this comes next. This divided by this is equal to this divided by this. Like you can see here, and that is the common ratio. A plus 12 divided by A plus 6y. A plus 12 just comes after A plus 6 is equal to A plus 21 over A plus 12. Why? A plus 21 comes just after A plus 12. And then doing the cross multiplication, this expression is simplified further in this way. And this arises to a quadratic expression, or rather a quadratic equation. So let us see how it is solved. It boils down to a squared plus 24a plus 144 is equal to a squared. So cancelling the a squared, and then in fact it is not a quadratic. It will be very easy. You just cancel a squares because they'll cancel one another, and then it's going to be a linear equation. So 24a, right, like that, then the value of a is 6. The first term of the GP is 6, but we have not been asked the first term, but we are going to use it somewhere else. Now let us go. Let us continue. Find the sum of the first 9 terms of the GP to 4 significant figures. Now, you might be wondering why we have not used the geometric series formula. So we are going to use it now. In this question, we are given the number of terms n. So we are going to substitute n here in this formula, 9. Okay. R, we have R, we are not given. We need the sum of the 9 terms, but we can get R since we have an expression. This expression here, 6, because A is 6 plus 12 over 6 plus 6. Where has this expression come from? This is where it has originated from, the one that we had formulated. So 6 plus 12 over 6 plus 6 is equal to 3 over 2. And that is how we get R. We substitute R, the value of R, in this equation here. And I think this is where this is how the substitution has taken place. And then we substitute 9 as n, because the value of n is 9. And then after working it out, doing the evaluation, we arrive at 591.1. That is in 4 significant figures. So let us now go to the next question. The product of the first 3 terms of a geometric progression is 64. The product, if the first term is A and the common ratio is R, express R in terms of A. So here we got to understand what the question demands. The product. The product means we are multiplying the 3 terms of the geometric progression. And after we multiply the 3 terms, we have to arrive at 64. The question is telling us to get the common ratio, having that information. And so A times AR times AR squared is equal to 64. A cubed times R cubed is equal to 64. Dividing both sides by A cubed and getting the square root, R is the cube root of 64 over A cubed, which is going to give you 4 over A. Going to give you 4 over A. I don't know why it was not written. Maybe it was a mistake. It should be 4 over A. So I'm sorry for that omission. There was an omission. This is the answer, is equal to 4, because cube root of 64 is 4. The cube root of A cubed is A. Now let us go to the next answer, the next part of the problem. Given that the sum of the 3 terms is 14, the sum of the 3 terms is 14. Find the value of A and R, and hence write down 2 possible sequences, each up to the 4th term. So we have the formula. The value of A is not given. The value of R is 4 over A, is 4 over A, 4 over A. The value of N is, 14. And here the value of R is 4 over A. What about here? Sn. Sn is given the sum. Sorry, this is not 14. This is not 14. Where is my rubber? Where is my rubber? Here is my rubber. Let me rub here. Yes, that is not 14. 14 is the sum. So after doing Well, how many? There are 3. So there are 3. We have 3 terms. So 3 minus 1, that will be squared. Now, doing the manipulation, A plus AR, you can use that formula. I was trying to look at the substitution, but you can use that formula. Now, let me mention something here. I would like you to verify the answer using this formula. We have not used this formula in our example, but I would like you to verify using that formula. So we have just tried to do manually. Yeah, the first term is A, the second term is AR, the third term is AR squared, and then is equal to 14. So where we have R, we have substituted in the 4 over A. Where we have R, it's 4 over A. A squared is equal to 14. So A plus 4 plus 16 over A is equal to 14. After doing the simplifications, and the question boils down to a quadratic equation, which is A squared minus 10A plus 16 is equal to 0. Evaluating for A, you get A is equal to 8 or A is equal to 2. Remember that this is a geometric progression. It's a geometric, is a quadratic equation where 2 possible values can be evaluated. Now let us look at how to get the value of R now that we already gotten A. R is simply a half or 2. How is it come to be? So R is equal to 4 over A. Let me change the color. Where we have A, we substitute with 8, and then cancel, you get a half. Or if it is 4 over A, well, if it is 2, we cancel, then we get 2. So the second value of A is 2, as shown in the next part. Then the question is asking, find the value, hence 2 possible sequences. 2 possible sequences. The first sequence is 8. First sequence is 8, 4, 2, 1. We are going to apply the formula for getting geometric progression, where the first term is 8. Now this sequence is a sequence in a descending order. This is in ascending order. This is in descending order. This one is in ascending order. Let us look at the first terms. The first term is 2 or 8. So this one is not there. Let us assume that. Point of correction, that one is not there. So it's 2, 4, 8. Don't have 1. 2, 4, 8. 2, 4, 8, and so on. So those are the possible sequences in this particular geometric progression. That is the end of the tutorial. Hope to meet in the next video tutorial. Thank you.